Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there was no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the Moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the Moon. Approaching the Moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the Moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the Moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the Moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the Moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the Moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our Moon and prove that together we are ready to go beyond.
All right, lift off and the clock is starting.
wherever, however, whenever. We're here, there. We're everywhere. NASA Space Communications and Navigation. Exploration enabled.
Hello, I'm NASA Associate Administrator for Science, Thomas Zurbuchen. NASA is going to the moon with the Artemis program, and American companies of all sizes want to help our nation make its next giant leap. It is my pleasure to announce the companies who are joining the pool of NASA industry partners who will help our nation enable the first woman and next man to reach the lunar surface by 2024 and conduct significant science investigations. Through NASA's commercial lunar payload services, we're sending science and technology demonstrations to the lunar surface beginning in 2021. These payloads will help us study the moon and prove technologies that will need to eventually travel to Mars. Today, 5 new companies joined this great initiative. I want to congratulate the new CLPS participants: Blue Origin, Ceres Robotics, Sierra Nevada Corporation, SpaceX, and Tyvak Nano Satellite Systems. We look forward to working with all of you. Together we are going.
It's great to be going back to the moon. An opportunity like this is the reason why many of us got into the space industry. Blue Origin will be offering its Blue Moon lander, the one that we've been working on for several years. With its BE-7 engine that we've been test firing at Marshall Space Flight Center, to the kilowatts of power it will provide to help it survive lunar night, to its flexible payload deck that will support everything from instruments to rovers, we're confident that this lander can support all of our needs, from exploration to science, as America returns to the surface of the moon, this time to stay.
We're delighted to have the opportunity to participate in NASA CLPS program and to provide landers and deliver payloads to the moon's surface. Over the last 60 years, NASA and its partners have created the opportunities we have today to go back to the moon, to go onto Mars and beyond. Our thanks to NASA and all who have made this possible.
Hi, Steve Lindsay here. I'm Senior Vice President of Strategy for SNC Space Systems Business Area. SNC is thrilled to have been selected for commercial lunar payload services to support Artemis missions and the next stage of lunar exploration. For CLPS, we'll be applying experience and knowledge from our Lunar Gateway programs, satellites, and cargo resupply services for Space Station through our Dream Chaser spacecraft. CLPS is an amazing opportunity to advance science, exploration, and learn more about the lunar surface. Thank you, NASA, for your trust. SNC is proud to partner with you again, and we can't wait to get working on CLPS and many other programs.
Hey everybody, we are super excited that NASA selected us for the CLPS program. I think Starship is going to be an extraordinary help and benefit to deliver both science, technology, and even cargo to the lunar surface. Starship is a great vehicle. It's fully reusable, so not only can it take a lot to the surface of the moon, but it's also quite affordable. Thanks to NASA, we are the company that we are today, and we're really thrilled to continue the partnership on the CLPS program.
We look forward to working with our partners and apply flight-proven expertise to design, develop, and operate a lunar lander to the moon's surface. We continue to value our relationship, and we'd like to thank NASA for including us in such an instrumental project.
Earth is my favorite planet.
My favorite part about planet Earth is the ocean.
So my favorite part about Earth is there's life here. We know that there is life here. There's so many aspects of it. I mean, the very fact that we're here.
My favorite part about the Earth is the Arctic.
That feeling before a thunderstorm.
I enjoy the feel of the wind.
When you fly, when you are on an airplane, and you are in between two decks of clouds.
There are so many different environments on Earth that we are just now exploring in the past few decades.
It actually floors me that we have such a large area on this planet that is, basically relatively unexplored.
The depths of the ocean.
To see that life flourishing under the water.
I think it's fantastic.
I feel like the best thing about planet Earth is that it's so close to the moon, and the moon is awesome.
The Earth has a large moon that keeps its climate stable by keeping its pole stable.
Coming back up to where does our atmosphere end?
The feedback between life and our climate.
How far out can microbes live?
I like how sunlight interacts with Earth.
How that influences the sea ice.
I just love the diversity of life on Earth and all of the places that it can thrive. It's pretty amazing.
We set sail on this new sea because there is new knowledge to be gained. But why, some say, the moon?
But why, some say, the moon?
But why, some say, the moon?
Why choose this as our goal?
And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic?
Why does Rice play Texas?
We choose to go to the moon.
We choose to go to the moon.
We choose to go to the moon.
We choose to go to the moon in this decade and do the other things.
Not because they are easy,
but because they are hard.
Because that goal will serve to organize and measure the best of our energies and skills.
Because that challenge is one we are willing to accept.
One we are unwilling to postpone.
And one which we intend to win.
And one which we intend to win.
And one we intend to win.
My name's Naomi Atkins.
And my name's Kelly Marie Tran. And we're at NASA's Johnson Space Center.
And we're training to be astronauts. No big deal.
Oh, big deal at all. We got this. Come on, let us do it. Let's go.
The first thing we're going to show you this morning is what's called a gravity offload system. So people often think that we have a room here where you can go in and flip a switch and suddenly you're floating. That's not really how it works.
You want to see how it works when you're 1/6 your weight or 3/8 your weight. We use Argos to do that. And then we use it to work on like new tools, new geology, sampling procedures. So from here, what we do is we'll lift you up off the ground.
Oh my God!
And we'll put you into lunar gravity.
What is that?
All right, so this right here is zero gravity. So if you're at the space station and I were to push you and say, see ya, you're just gonna put him away the way I push you.
So what did you guys think of that? It was so cool. I was saying I realize now why astronauts walk like this.
Yeah!
Because everyone's just like trying as much as possible.
Do you guys want to go check out suits?
Yeah.
Want to go try some on? Alright. Yeah! Next.
So we're going to talk to you a little bit about spacesuits today. We're going to move some suits over here, I think, real quick, and we'll talk to you a little bit about what they are, and then we're going to let you guys change and actually try them out.
So you go out there and there's no air. So then there's pressure pushing in on your body?
So what we would have to go through is your body would want to expand out, so that's why we wear a suit around us that goes through and creates an artificial atmosphere.
Do you guys have training in terms of how quickly you can get in and out of these? Is that a thing?
No, I mean you have to know your spacesuit really well, but we don't do drills like getting in them quickly. You typically are helping each other, getting into and out of them when you're in space.
And so those tubes actually are going to create cold water to help us cool. We'll see what that feels like once we get inside. These guys are going to help you get climb entrance.
Yeah, like Chewie.
The guy who plays Chewbacca.
Stand up. Well, unfortunately, we're going to get you guys out of the suit now, but then we're going to take you over and see the vehicle that you would be in these suits in.
Okay.
In the Orion vehicle.
This is the Space Launch System. This is what's going to push this capsule. This is the Artemis 1. This is going to go to the moon about 1 year from now.
Yes! Oh my gosh! Yes! Okay. 9 it.
This is the docking hatch up here. When we get to the gateway, we will dock at that port, and there will be a hatch up there that we open to go into the gateway.
You have to like target, right? So you have to like figure out a way to drive the rocket so that the holes match up.
Bingo. You know how precise it is? First of all, relative to the Earth, we're going over 20,000 miles an hour, and when we dock, meet up with this plus or minus 1 inch, plus or minus 1 degree in each axis.
That's really difficult.
Yeah, we actually make the switches, it's a multi-step so you don't accidentally hit a switch.
We're going to go check out the mock-ups for the space station, which will seem luxuriously large.
Okay, this gives you an idea how big of a room each person is. You can put up, So yeah, you do. You have a sleeping bag, as they mentioned, and you can pin that to the wall, and you can float kind of inside your sleeping bag. You can tighten it down if you would like to feel a little bit more stable.
This is Houston. Yes. This is when they actually say Houston, we have a problem. This is Houston.
So that's live.
They're in space right now. What are they doing? Oh my gosh, it's mad.
What's the day-to-day like in this room?
Yeah.
So in this room, we have 3 shifts a day. My favorite shift is the night shift because it's when nobody's in this building, but we get to hang out with the crew.
Are you guys ready to try some space food? That's next on the list.
Where do you get the suggestions of what to work on next?
That's a great question. We get a lot from the crew office, or the crew office says, can we move away from red meat and potatoes and get Brussels sprouts, butternut squash? And this comes from a lot of crew comments as well as input from the nutrition line here at JSC that says, you guys should probably go with the salt in there. So on station, the astronauts have a much more advanced dehydration apparatus. They have the potable water dispenser. The astronauts can help you with figuring out how to unlock the straw.
Because otherwise, so that way when you set it down, liquid's not going to come up on that part.
Stuff is at the bottom, so you want to like.
She knows the tricks of the trade. Yeah.
Which one is your favorite?
I would say the butternut squash is my favorite. But I like things that are sweet.
I like the Brussels sprouts, I think.
They're so good.
All right, well, you guys have had your afternoon snack. Now you ready to go drive a lunar rover? All right, let's go check it out.
I really don't know how to drive. This is like going to be a
Oh,
What is that? Oh, it's a air.
It's air conditioning.
It's air conditioned?
Twist. Yep.
This is so cool.
On the lunar surface, it'll basically be, you're in the rover, like Megan and Jessica will be in the rover for up to 14 days, living together. And there'll be another rover, they'll go out for 14 days and explore. And if one breaks down, all four of you will jump in one vehicle.
I think I made contact. I think we're there.
Awesome.
We're there.
Yeah.
That was
Nicely
smooth.
done. That was awesome.
Dude, what an amazing game. It's been really good. It's been amazing. It's more than I expected. Yeah. I have so much respect for NASA. Yeah. Thank you for bringing us here.
And as we leave the moon, we leave as we came, and God willing, as we shall return.
You probably dreamed of this.
Liftoff on Apollo 11.
You probably replayed this moment 1,000 times. You probably imagined the awe-inspiring, indescribable rush of the ride. You probably celebrated the miraculous, cheered the momentous, and mourned the shocking. You probably still dream of what could be. We did. We do. And while many thought we were through, no. We've been learning, we've been building, we've been training. And now, it's time. Because the next frontier is not just for the next generation. It's for this generation. It's for me, and it's for you. For everything we still dream about. We go as Artemis.
Space travel is hard and unforgiving. It's always been and always will be.
It's going to be hard. There's a new chance of death. Going in a little can through deep space, it's a very harsh environment.
We think you can come back, but nothing is certain.
There are all sorts of challenges we will face on deep space missions. Communication delays, radiation protection, isolation of the crew.
So it is not surprising that some would have us stay where we are.
There's never going to be zero risk. When you're breaking the bonds of gravity, that's just part of the deal.
And it is one of the great adventures of all time.
Okay, all flight controllers, gonna go for landing. Retro. Go. I don't go. I go.
That challenge is one that we're willing to accept.
Surgeon, go.
Man in his quest for knowledge cannot be deterred.
Space is not just a destination. It changes you forever.
It'll be tough, really tough, but we have the right people for the job.
We have pressed the qualities of success into system
lunar system.
This country of the United States was not built by those who waited and rested.
Pushed our people past every failure we can dream up.
We have never been more ready to meet the unknown.
Through Artemis, we will once again explore beyond our world.
And we will succeed.
Hello, I'm NASA Associate Administrator for Science, Thomas Sherbuchen. NASA is going to the moon with the Artemis program, and American companies of all sizes want to help our nation make its next giant leap. It is my pleasure to announce the companies who are joining the pool of NASA industry partners who will help our nation enable the first woman and next man to reach the lunar surface by 2024 and conduct significant science investigations. Through NASA's commercial lunar payload services, we're sending science and technology demonstrations to the lunar surface beginning in 2021. These payloads will help us study the moon and prove technologies that will need to eventually travel to Mars. Today, 5 new companies joined this great initiative. I want to congratulate the new CLPS participants: Blue Origin, Ceres Robotics, Sierra Nevada Corporation, SpaceX, and Tyvak Nano Satellite Systems. We look forward to working with all of you. Together we are going.
It's great to be going back to the moon. An opportunity like this is the reason why many of us got into the space industry. Blue Origin will be offering its Blue Moon lander, the one that we've been working on for several years. With its BE-7 engine that we've been test firing at Marshall Space Flight Center, to the kilowatts of power it will provide to help it survive lunar night, to its flexible payload deck that will support everything from instruments to rovers, we're confident that this lander can support all of our needs, from exploration to science, as America returns to the surface of the moon, this time to stay.
We're delighted to have the opportunity to participate in NASA CLPS program and to provide landers and deliver payloads to the moon's surface. Over the last 60 years, NASA and its partners have created the opportunities we have today to go back to the moon, to go onto Mars and beyond. Our thanks to NASA and all who have made this possible.
Hi, Steve Lindsay here. I'm Senior Vice President of Strategy for S&C Space Systems Business Area. S&C is thrilled to have been selected for commercial lunar payload services to support Artemis missions and the next stage of lunar exploration. For CLPS, we'll be applying experience and knowledge from our Lunar Gateway programs, satellites, and cargo resupply services for space station through our Dream Chaser spacecraft. CLPS is an amazing opportunity to advance science, exploration, and learn more about the lunar surface. Thank you, NASA, for your trust. SNC is proud to partner with you again, and we can't wait to get working on CLPS and many other programs.
Hey everybody, we are super excited that NASA selected us for the CLPS program. I think Starship is going to be an extraordinary help and benefit to deliver both science, technology, and even cargo to the lunar surface. Starship is a great vehicle. It's fully reusable, so not only can it take a lot to the surface of the moon, but it's also quite affordable. Thanks to NASA, we are the company that we are today, and we're really thrilled to continue the partnership on the CLPS program.
We look forward to working with our partners and apply flight-proven expertise to design, develop, and operate a lunar lander to the moon's surface. We continue to value our relationship, and we'd like to thank NASA for including us in such an instrumental project.
My whole life, I'd always had this amazing dream that, the best thing you could possibly do was work for NASA.
We were watching, the moon landing. And I told Mom I wanted to go to the moon. That day I told Mom that I wanted to go to the moon. And, you would think that Mom would be negative about the whole thing. basically what she told me was you can be anything that you want to. Just put your mind to it and work hard, and you never know.
My mother was an aeronautical engineer. She was just a no-nonsense, I'm gonna work hard and I'm gonna get the job done, and she did. To me, that was just a tremendous inspiration for me as a young woman, seeing that a technical career and that a career in leadership in a mathematical or a scientific field was possible.
The best mentors that I have ever had have been those people who helped me figure things on my own, not tell me what to do, but they, through questions and answers, they extract what is it that I want to do and where I want to go.
People that just gave me confidence and gave me the idea that I could do it and I should try, because there's nothing wrong with trying.
We have the power within us to really be whoever we want to be, and if we want to be engineers, scientists, or astronauts, or whatever, what have you, that we can do that. It is important to have the diversity, not just in disciplines and technical expertise, but walks of life.
I have many times found myself to be the only woman in the room. There's really been a tremendous emphasis over at least the last 10 or 15 years in really making sure that we provide opportunities, that there are opportunities for women to excel and to work in leadership positions, and I'm seeing more and more and more of that.
For those young girls nowadays that are growing up, they can see so many role models and so many examples and so many places they can say, I want to be like her.
People are just inspired by what NASA does, and people look at you differently when I'm on a plane and they see my NASA pin, and they're the first thing they say is, "Oh, do you work for NASA?" And you'd say, "Yes, I do."
So I think it is important that the girls have the role models, because they cannot be who they cannot see.
There are people who understand what you've been through, and you've got to just keep pursuing and be persistent, and there'll always be, you got to have the first one there, so keep going.
If you love something so much, you will be successful because you put your heart and soul into it. Follow your dreams, because they'll always take you to success.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
T-minus 60 seconds and counting. We are go for Apollo 7 at this time.
And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth.
We have ignition sequence start. Engines on. 5, 4, 3, 2.
Listen, Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind. We leave as we came, and God willing, as we shall return, with peace and hope for all mankind. Right away, Houston.
From 1969 to 1972, we had, a total of 6 moon landings. 12 humans walked on the surface of the moon. We have elevated the human condition. We have improved human lives. We have raised the standard of living for every person on Earth because of space exploration. We're going to go back to the moon, and we're going to take what we learned there, and we're going to go to Mars.
We set sail on this new sea because there is new knowledge to be gained. But why, some say the moon?
But why, some say the moon?
But why, some say the moon?
Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic?
Why does Rice play Texas?
We choose to go to the moon.
We choose to go to the moon.
We choose to go to the moon
we choose to go to the moon in this decade and do the other things.
Not because they are easy,
but because they are hard.
Because that goal will serve to organize and measure the best of our energies and skills.
Because that challenge is one we are willing to accept.
One we are unwilling to postpone.
And one which we intend to win.
And one which we intend to win.
And one we intend to win.
I've definitely drawn encouragement from mentors that I can see reflections of myself in throughout my life. And so recognizing that we may be offering that for future space explorers or explorers of any kind or anyone pursuing a dream was definitely a privilege and an honor.
This year, 5 new missions are taking off to investigate our home planet. From coast to coast, these missions will take a closer look at everything from sea level rise to snowstorms, all based right here in the United States. About 200 miles off the coast of San Francisco, the Submesoscale Ocean Dynamics Experiment, or SMODE, will use measurements from a research vessel and 3 planes, a King Air, a Gulfstream, and a Twin Otter, to look at how swirling ocean eddies affect the movement of heat between the ocean and the atmosphere. Autonomous wave gliders and ocean gliders will dive below the surface of the water to get a full picture of the ocean and atmosphere. Together, the mission will collect data about temperature, salinity, and ocean velocity to get a better understanding of how small eddies affect the upper ocean. Traveling inland to the Midwest, the summer months can bring intense thunderstorms. Strong winds formed by these storms can overshoot the troposphere and reach higher in Earth's atmosphere, injecting pollutants into the stratosphere, which can affect the ozone layer. Using an ER-2 plane flying up to 70,000 feet, the Dynamics and Chemistry of the Summer Stratosphere, or DCOTS mission, will investigate how the pollutants reach the stratosphere and how their impact could change in the future. Farther south, the Mississippi River Delta is sinking as sea levels continue to rise globally. The Delta X mission, no acronyms here, will combine measurements from 2 planes, a King Air and a Gulfstream, with measurements taken on the ground and in the water to study how and where soil is naturally transported and deposited by water. This can help researchers better understand how the coastal regions will be affected by rising sea levels. On the east coast of the United States, the Aerosol Cloud Meteorology Interactions over the Western Atlantic Experiment, or ACTIVATE mission, will look at how clouds in the marine boundary layer, roughly the 2 kilometers above the ocean, affect the water cycle. These cloud systems cover large stretches of the ocean and are not well represented in climate models. ACTIVATE will use 2 planes, a Falcon and a King Air, to take measurements remotely and in situ, including releasing dropsondes through the clouds. Flying the same corridor, the investigation of microphysics and precipitation for Atlantic Coast Threatening Snowstorms, or IMPACTS mission, will use measurements on the ground, scientific balloons, and 2 planes.
Hi, I'm Nikki Fox, and I'm in charge of all sun science here at NASA. This is Ask NASA, and I'm here to answer your questions. Is the sun a ball of fire? No, it's not. We know that the sun can't be a ball of fire because we need oxygen to be able to have combustion, and there's no oxygen in space. The sun, however, is a giant nuclear furnace. The core in the very center is very, very similar to a nuclear reactor, and all of these particles get squashed together, and there's a huge amount of pressure, and they undergo chemical reactions, and so there are very different layers as you move out towards the edge of the sun. Why does NASA send missions to the sun? Because the sun is the most important thing in our solar system. The sun generates light, but also a tremendous amount of energy, and it sends all of this material to us here on Earth. And so we live in the extended atmosphere of the sun. We've looked at the sun in every different wavelength, but recently NASA launched the Parker Solar Probe, which is a daring mission to go into the very atmosphere, the very heart of the atmosphere of the sun. So I have a model of the Parker Solar Probe spacecraft here. Could I get some sun in here, please? So the important thing is, as the spacecraft moves around the sun, the heat shield has to remain pointed towards the sun at all times. So the heat shield, the front of the heat shield, will get to about 2,500 degrees Fahrenheit, but the main body of the spacecraft is nice and cool at about 80 degrees Fahrenheit, which is a bit like a balmy Florida evening in August, I guess. And that's Parker Solar Probe. Thank you. Good. Right you are. So one of the things that we discovered with Parker Solar Probe on the very first orbit was switchbacks. Switchbacks. If only I had a model of the corona. Oh, thank you. So switchbacks are really reversals in the material coming from the sun. So the sun has a magnetic field, and that is continually moving away, or so we thought, continually moving away from the sun. But what we found with Parker Solar Probe is this magnetic field actually kind of reverses on itself and makes an S shape, and we call that a switchback. It's hard to twist a magnetic field. It's like trying to twist a rubber hose. It's hard, and so somehow there's this energy going into the magnetic field that's causing this S shape, and when it releases, it's letting all of this excess energy out into the solar wind. Thank you. Studying the sun is really important as we get ready to support the Artemis mission. We're really protected here on the planet by our magnetic field and all of that atmosphere around us. Our astronauts, when they will be on the moon, and of course as we journey further to Mars and beyond, we'll be traveling through the solar wind and living really more in the atmosphere of the sun. And so it's key as we go forward to the moon, to Mars and beyond with our Artemis mission, that we really understand the source of energy in the heart of our solar system. Parker Solar Probe, on her final closest approach, after she's done all of those Venus flybys, she will be at about 3.9 million miles above the sun's surface. We have many materials on Parker Solar Probe that don't melt despite how close they are to the sun. In fact, that was one of the big technology challenges for us, to find materials not only that don't melt, but can actually withstand the incredible change in temperature, because Parker goes very close to the sun and then comes out around the orbit of Venus, which means that all these materials go really hot and then really cold at least 24 times. So the critical thing for Parker Solar Probe, of course, is to keep that heat shield pointing at the sun. At some point, she will run out of fuel. At that point, unfortunately, she will start to turn, and the full illumination of the sun will hit parts of the spacecraft that are not designed to see the sun. And so she'll break up into large pieces, and then they will get gradually smaller and smaller until they become really tiny. And so I like to think that she will become part of the corona, and she will orbit the sun forever. So honestly, we don't know what new science we're going to expect. We've already seen unbelievable stuff on our first couple of orbits. Science is a voyage of discovery, and that is what Parker Solar Probe is doing. She is going into a region where we've never been before. And so honestly, we expect the unexpected. My favorite aspect about the sun is it's a star, and it's a star that we can go and visit. And so you think, you look up in the night sky, you see all of those stars, and yet we're actually sending a spacecraft right into the atmosphere of a star right now. And that means we're going to understand more about other stars in our universe, and that's amazing.
Do you have a question for NASA? Send your questions to our experts on Twitter using hashtag AskNASA.
All right, lift off and the clock is starting.
Wherever, however, whenever. We're here, there. We're everywhere. NASA Space Communications and Navigation. Exploration enabled.
Spacewalkers resume battery upgrades aboard the space station, a post-flight visit from a couple of recently returned space station astronauts, and a key piece of SLS hardware moves closer to a critical test series. A few of the stories to tell you about this week at NASA. On January 15th, our Jessica Meir and Christina Cook ventured outside the International Space Station for a spacewalk, the first of two they will conduct this month, to complete the battery upgrades started on the station last year. Meir and Cook are scheduled to be back outside the station on January 20th. Then, if all goes as planned, on January 25th, our Andrew Morgan and Luca Parmitano of ESA are expected to conduct the station's third spacewalk this month. On that outing, the pair will finish the installation of the Alpha Magnetic Spectrometer's new cooling equipment that began late last year. Former space station crew members Anne McClain and Nick Hague were in the Washington, D.C. area for several post-flight appearances, including a short presentation for employees at NASA headquarters. Also appeared on a segment of the Smithsonian National Air and Space Museum's What's New in Aerospace. McClain and Hague spent more than 6 months in space and conducted a combined 5 spacewalks. The first Space Launch System rocket core stage for our Artemis program arrived at our Stennis Space Center in Mississippi on January 12th aboard the agency's Pegasus barge. Engineers there will use the center's B-2 test stand to conduct a series of integrated tests with the core stage known as the Green Run Test Series to verify that it is ready for launch ahead of our uncrewed Artemis 1 mission around the moon and back. We released new imagery of a test at our Glenn Research Center with Viper, the mobile lunar robot being developed to search for water ice at the moon's south pole. The golf cart-sized rover will be delivered to the moon through our Commercial Lunar Payload Services initiative before we land the first woman and next man on the moon in 2024. On January 15th, NASA and the National Oceanic and Atmospheric Administration provided the annual release of global temperature data. Independent analyses by both agencies found that Earth's global surface temperatures in 2019 ranked second warmest only to those of 2016 and continued the planet's long-term warming trend. The past 5 years have been the warmest years on record since modern record-keeping began in 1880. NASA uses the unique vantage point of space to observe Earth and to better understand the processes that affect our home planet. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. We're ready.
Fort Worth Academy, this is Mission Control Houston. Please call station for a voice check.
Station, this is Fort Worth Academy. How do you hear me?
Fort Worth Academy, we have you loud and clear. Welcome aboard the International Space Station.
Hi, I'm Lauren Parker with the kindergarten through 8th grade students of Fort Worth Academy. We're so excited to talk with you as we celebrate Space Week.
Hi, I'm Blythe from 1st grade. How does it feel to bounce around in space?
Well, it's a lot of fun. In fact, we thought we'd do a little demonstration for you. So as you can see, it's a lot of fun.
Hi, I'm Ellie from 5th grade. What would happen if you tried to play with slime in space?
That is a great question, and I hear that you guys have been making some slime as well. Here in space, there wouldn't be any gravity to pull that slime down in a long tendril, so actually it would probably just ball up in a ball, and if you wanted to slime somebody, you'd actually have to make it like a projectile and fire it at them. So it'd be a little different, but it'd probably still be just as fun.
Hi, I'm Lourdes from 8th grade. What role does the International Space Station play in the process of building a sustained presence on the moon?
Well, as I think you're probably already aware, it is our goal at NASA currently to go back to the moon and eventually go on to Mars. So all that we're doing up here on the International Space Station, a lot of the data and experiments that we've been conducting for decades now are providing us with a wealth of scientific data, especially looking at things like human physiology and medicine, what happens to the body after long-duration spaceflight. We have learned many lessons from this sustained presence that we have up here on the space station. The space station also serves as a sort of proving ground and test bed for other pieces of hardware. One of those important things is life support systems. Of course, life support systems inside the space station, in our spacecraft, even in our spacesuits, are all very relevant to that future exploration as well.
Hi, I'm Kason from 8th grade. What is it like knowing that you have an opportunity few people will have in their lives of living and working in space?
Well, we view it as a great honor, and we view it as our responsibility to share it with others. We know that we're very privileged to be here, and we have a huge team supporting us on the ground in order to enable this to happen. And so we like to do events just like this to reach out and show you the magic of being in space, but also the benefits to people on Earth, as well as our opportunities to explore further in the universe as a result of our experience up here.
Hi, I'm Kai from 5th grade. When you spill something like water on your clothes, do they get wet or does the water just sit on top?
Sounds like another great opportunity for a demonstration of what might happen. So we're making a big ball of water here, and you can see the forces in the water want to stay in a sphere, and it wants to stick to anything it can, to include the straw. We'll make another ball here, and I'll let it hit my shirt, and you can see exactly what would happen. Just like the water wants to stick to itself, stick to the straw, it also will stick to my shirt.
it does still get things wet as well. As you can see with Drew, if we squirt him with water, he still gets wet just like he would on the ground. It is interesting, though, some of the fabrics they provide us help us keep clean. So some of the pants, for example, that we have are a little bit more hydrophobic. They repel the water, and so it'll bead up on there, and you can wipe it off if you spill something inadvertently, since we do wear these pants for quite a long time.
Hi, I am Charlie from kindergarten. How have you celebrated holidays and other special events in space?
Sometimes we do like to remind ourselves of our normal life on the ground, even though, as we talked about, we're so lucky to be up here. So it is important for us psychologically, especially on these long duration missions, to recognize those things that we normally do on the ground, like holidays. So we've actually had several holidays together during this mission, some really big ones. We had Thanksgiving together, we had Hanukkah and Christmas up here during the holiday season, and we also had New Year's. So what we did, we get together with our crewmates, the three of us, but also our commander, Italian astronaut Luca Parmitano, and two of our Russian colleagues as well, cosmonauts that are up here with us and part of our crew. So we usually gather together and have a great meal together. We spend some time sometimes playing music, talking about, things on the ground. We gave each other presents on Christmas. So we do it much like you do on the ground, just even more special up here.
Hi, I'm Ella from 8th grade. How have your previous leadership experiences prepared you for your stay in space?
I love that question because before I came to the International Space Station, and before I was selected as an astronaut, I was and still am an Army officer, where we talk about leadership a lot. But what I've found as an astronaut, the important quality is being a good teammate, which means to be able to move between being a leader and being a follower very readily. On one day, one person may be in charge of it, but the next day somebody else may be in charge, and you need to then fall in and become a follower just the same. And so that's an important quality of a good teammate, is being able to move back and forth through those roles and respect whoever is in charge and their decisions. It's a